Now this set is all done the same. If we don't have a common base on both sides, then we have to write it as a logarithm. So 15 is a multiple of 3, but that doesn't help us. It's not a pretty power of 3. So we have to turn this into a logarithm. The base of the exponent is the base of the log. Since the base of the exponent is 3, the base of the log is 3 of 15 equals x. Stop. That's it. That's the exact value. Do not touch your calculator. You don't need it for this slide and the next couple slides. Log base 3 is a number. It's about 2 point something. The way we know that is because 3 squared is 9 and 3 cubed is 27 and 15 is between 9 and 27. So as a decimal approximation, it's 2 point something. But the exact value is log base 3 of 15. That's it. Part B, e to the 2x plus 1 equals 4. We're going to turn this into a logarithm because, again, exponential equation, but I can't easily write both sides of the same base. Since the base of the exponent is e, this turns into a natural log. Natural log of 4 equals 2x plus 1. So notice I'm doing is just putting things in the right place. Go back a couple of videos where we first learned how to transfer between exponents and logs to make sure you're comfortable with that. Now we'll subtract 1 from both sides. We cannot subtract the 1 from the 4 because the 4 is part of the logarithm. And now to finish, we'll divide by 2. So the exact value is the natural log of 4 minus 1 divided by 2. Part C is unfortunately a little bit trickier. We need to do a different technique. We can't immediately turn this into a logarithm, but what you're allowed to do is take the log of both sides. It doesn't matter what type of log you take. You can take a log base 2, log base 20, log base 10, natural log, as long as it's the same log on both sides. It's the same idea of adding the same number to both sides, taking the square root of both sides. That's all legal. You're just applying a function to both sides. We're going to do the same thing here. I'm going to choose a natural log, but again, it does not matter what type of log you make, or you use, I should say. Previously, in the black problem, the original one, there was no logs there, so there was nothing we can do with those exponents. Now that there's logs and the arguments have powers, according to the power rule, we can bring those exponents down in front. Again, you can't do that unless there's a log there. Natural log of 2 and natural log of 5 are just numbers, so just treat them as numbers. We're going to distribute them through. Now, I'm going to do something unconventional. I'm putting the x in front of the number. The reason being is if I put that behind the number, it might look like the natural log of 2x. And that's not what we want to display. It's the natural log of 2 times x. And we can get away with that by putting the x first. We need to solve for x. It doesn't look like it, but this is a linear equation. So when you have a linear equation, you want variables on one side and numbers on the other. So the things with one underline has a variable, so we need to get those on one side. And the thing with a double underline is a number, because it doesn't have a variable. We need to get that on the other side. Doesn't matter which side. I'm going to move this to the left by subtraction, move this to the right by subtraction as well. That gives me x times the natural log of 2 minus x times the natural log of 5 equals, I don't know if I'm going to fit this, negative natural log of 2 minus 6 natural log of 5. It barely worked. And then on the left-hand side, since both terms have an x, I can factor that x out, and I'd be left with the natural log of 2 minus the natural log of 5 equals the right-hand side. I hope you're writing small. And now we're multiplying x by just a number. So if that were like 2x equals 3, you would divide by 2 to solve for x. Well, in this case, we're multiplying it by the natural log of 2 minus the natural log of 5. So we'll divide both sides by that number. So we get the very, very pretty answer for x is negative natural log of 2 minus 6 natural log of 5 over natural log of 2 minus natural log of 5. Leave this alone. It's fine. Yes, there's a way to clean it up. I'm not going to care. If you want to clean it up, feel free. But it's an exercise in futility, to be honest. All right, part D. Just like our previous video, we can't multiply the negative 3 and the 10 because the 10 has got a exponent. So instead, we have to get rid of the negative 3, and the way we're going to do that is dividing both sides by negative 3. So we'll have 10 to the 3x plus 6 equals 50/3. Turn this into a logarithm. Since it's a base 10, we need a base 10 log. So just log. Do not write base 10. 50/3 equals 3x plus 6. And then to finish this one, we'll subtract 6. And then what do we do with that 3? We divide it. So our final answer is log of 50/3 minus 6 divided by 3. So again, all 4 of these were done the same way. We could not write both sides as the same base, so we need to turn it into a logarithm.